Okay, so I was working today on using the geometry shader to produce cool things. Specifically for the background of the space trader, I chose to start with the color turquoise. Just happens to be a nice color. So this is actually the geometry shader. So you got your vertex shader there, and then a fragment shader there. So the way that this works is the this is the class of the program. It's well, let me just show you. This point is hardwired in. There's actually 5 points, but we're only drawing one. Although at this point we can do five. We can draw all 5 points, but that might look really cool at this point now too. So so how this works now is each point that goes through the pipeline, excuse me, can be amplified or culled in the geometry shader. So if you do nothing in geometry shader, you're going to cull your points. But in this case, layout points in, so it's getting a point in, okay, and then for every point, max vertices equals 256 out. So you can basically convert each point to 256 points and do whatever you want in the geometry shader. So it's allowing you to put a geometry amplification algorithm, that's a mouthful, onto the geometry shader, and it's executed by the GPU instead of the CPU. So long story short, with this one, there's a radius and there is a size that is computed, and then a start color, which is turquoise, and then this little doodad here, it just loops through the number of points that is sent in, which in this case, the primitive is a point, so there's only one. So the length is going to be 1. If it were a triangle, the length would be 3. There are others to do length of more, and you can send in whole primitives too. You can send in an entire model if you want to deal with an entire model's but that's beyond the scope of this video. This is like first geometry shader demo modified slightly. So here's the basic algorithm that I did to make 256 points. The angle is set to basically there's a single point, and what I'm doing is amplifying it to 256 points, but each iteration through here, because I wanted to make up to 256 points, is going to create, well, how this works is every time you get to emit vertex, it creates a new point. So you basically set up a vertex shader inside of your geometry shader, and then you call emit vertex, and then the state of the shader's variables at that point gets sent to the fragment shader as if the vertex shader were running. For example, in the vertex shader, you would normally have a color out. You would have a point size out if you're using point size, which I am. And you would have a position that would go out. And that's all you would need for your vertex shader. And then you would just end it and call the fragment shader. Well, that's what emit vertex does in the geometry shader. So it allows you to programmatically define what is happening in the vertex shader, and then emit vertex, it says send that to the fragment shader when you're done. And then it does all this, excuse me, 256 times. The center was kind of getting small, so I decided to put in a little if statement that if the size was greater than 5, and basically they all kind of there's a random function that I used that I found in a OpenGL Redbook, or the OpenGL Supervival, I can't remember which one. Anyways, they had it in their sample code, so I just used that. I took out the iterations because I just want one iteration of the random seed, although it comes up random with the same random every time, which is kind of cool, but anyways. So then I added another thing to this shader that I just finished adding a few seconds ago, is a uniform. And it's a float, it's a time variable, and I and that's what I did with the angle right here. I set the angle that the points are centered around to be dependent upon the time variable so that they would appear to rotate around the center of this point that is drawn. In this case, we're going to draw 5 points. I'm going to actually see what it looks like. And the time variable is sent in from glfw get time and as a uniform. So it gets shader program, time var, get uniform location, send a float, get time. Okay. So let's just see what it does. And isn't that cool? This is literally drawing 5 points and amplifying each point programmatically in the geometry shader and then sending in a uniform time variable and recalculating the position of the points on the GPU instead of on the CPU. So I don't know, it looks pretty cool. I'm going to capture a screenshot there too. So, all right, well, stay tuned for more. I'm not really sure what I'm going to do with this, but it looks really hypnotic. I think I'm falling asleep. No, just kidding, just kidding. All right, thanks for watching.